In this video, we're going to talk about interfaces. If you ask somebody what is an interface, they're going to say an interface is a collection of abstract methods and constants, which is right, but how does it make sense? And if you ask them what is the purpose of interfaces, then they're going to say the purpose of interfaces is to solve the problem of multiple inheritance, which is also true, but that's not it. Interfaces are not introduced to solve the problem of multiple inheritance. There's a different purpose to it. We're going to take a look at how it solves the problem of multiple inheritance, but let us try to understand the actual intent of introducing the interfaces. Take a look at this. Let's say there are three software companies, S1, S2 and S3, and they all specialize in providing the source code for robots. Let's assume they have class files, say R1, R2 and R3. Inside these class files, they write the source code for the robot. So it can have methods like move, and inside this method it will have some instructions to instruct the robot to move. Similarly, there can be stop method, etc. In here, this can have walk method and halt method. In here, it can have again walk and pause, so on and so forth. If you observe, the task performed by all these methods, stop, halt and pause, is essentially to stop the robot. The goal of this method is ultimately the same, is to stop the robot. Keeping that in mind, let's assume that you have a robot, and since you're not such a big techie, you can't write a code similar to this by yourself. All you know is basics of Java. You know how to create an object of a class and make use of the methods inside that class. Nothing more than that. So since your knowledge on writing the code is pretty limited, what you're going to do is you're going to purchase the code from company S1, essentially the class file, the bytecode of the source code, and what you're going to do is you're going to create an object of this class R1, a new R1, and make use of all the methods inside it, object.move and object.stop, etc. Now we have a very serious problem here. Can you guess what it is? Let's assume that you realized that the code provided by company S2 is more relevant for your purpose, and you thought the code provided by company S2 is more efficient and is performing the task faster than the source code provided by company S1. So you just wanted to switch to this source code. So what you're going to do is, instead of R1, you're going to say R2, which is a class file from this company. But how do we make changes in here? For example, instead of the method move, you're going to have to use the method walk. Instead of the method stop, you're going to have to use the method halt. So for this purpose, you need to go look at the documentation and try to understand what they're doing. You need to try to understand what their source code is doing to be able to make changes to your code. And we're just talking about a single class file, but in reality it would be an entire project. It's pretty time consuming and a messy process to make changes everywhere. Now in future, let's say you wanted to move to some other vendor, maybe S3 company, then you will end up doing the same. It's a pretty painstaking process. How do we get rid of this problem? The solution is interfaces. You can think of an interface as an abstract class, except the difference is interfaces will not have methods with behavior. Of course, with the introduction of default methods in Java 1.8, you can have some behavior written. We'll talk about it at a later point of time, but for now, assume that an interface can only have abstract methods and constants. So the syntax of defining an interface would be something like this. We're going to take a look at the example in our next video, but just for the sake of this example, let's see the syntax. For abstract class, you're going to have to say class abstract class name, and you will have the signatures of the method. But coming to interface, instead of class, you're going to say interface, and you get rid of this word abstract because it is implicitly assumed that it is abstract. Let's call this I1. I stands for interface, and all you're going to have is signatures of these methods, and you don't have to explicitly mark these as abstract because the Java compiler does that implicitly. Whatever the methods you have in here will be marked as abstract methods, and whatever the variable that you have in here, say int x equals 10 or whatever, by default compiler will assume them to be of final static. You can't have a variable that is not of final static. Essentially, you're just going to have only the constants in an interface. But coming back to our example, how does an interface solve the problem? All these companies, S1, S2, S3, they're going to have a small meeting and they're going to discuss about their problems. They found out that customers are finding it difficult to move to a different vendor. The guy from S1 says, there's a customer who is interested in taking our code, but he's not taking our code because there's a lot of tasks involved in making changes. Same is the problem with other companies as well. So all these three companies will come to an agreement that whatever the class files that we write will have the same signature for their methods. And the way of standardizing that process is through an interface. So all these three companies will discuss and figure out an interface for a typical robot. It will have all the method signatures like maybe walk, run, navigate, whatever. Whatever are the typical behavior of a robot, they will decide and put it inside this interface. And all these class files in here are going to implement this interface. So instead of saying extends, let's call this interface I1. So instead of saying extends I1, we're going to use the keyword called implements. Again, we're going to take a look at this example in our next video. Implement I1, and everybody is going to do the same. Implement I1, and by doing so, all these class files are forced. They're forced to give some behavior for all the methods inside that interface. Now, how is this solving the problem of the customer? Let me explain you. The customer, I mean you in this example, instead of saying R2, he's going to create a reference type of this interface, I1. So instead of R2, he's going to say I1. And this reference type of interface will point to, say, this class object, R2. Now by doing so, he can only access the methods that are defined inside this interface. He can't access the method move anymore. He's going to access the method walk, whatever is there in the interface. Now in future, if you decide to move to a different vendor, all you have to do is to change the object to which this reference type is pointing to, say R3, something like this. Now you don't have to make changes anywhere else in the code. The reason is, since everybody inherited or implemented this interface and you use that interface as the reference type, the methods are going to remain same for all the vendors. Isn't that amazing? So from your perspective, by using an interface, you have the flexibility to switch to different vendor as and when required. At the same time, there is improvement in the maintainability of the code and the time it takes to make changes to your code. Also, if you're switching to a different vendor, you don't need to know the internals of their code, and you don't need to understand what their code is doing. For example, without the interfaces, instead of stop method, you'll have to figure out what your new vendor is using and make changes here. But with the interfaces, no matter which vendor you use, you're going to have the same method. So essentially, all these vendors will expose this interface and make it public to everyone. And people like you will look at this interface. They don't look at source code. So this is kind of like an abstraction mechanism, which is also one of the major features of object-oriented programming language. And also these vendors will keep this source code proprietary. They don't want to expose it and make it public. So, but still they can just expose only the limited details like the method signatures by exposing the interface. On the other hand, the benefits that the companies like S1, S2, S3 will have is again the flexibility that they're offering to their customers to switch to a different vendor. In a way, all these companies are forced to implement this interface. The reason is only if the company implements this interface will the customers like you prefer their code. And also another benefit is, let's say there is no interface, and if they make changes to this method definition, then whoever or their clients, they all end up getting compilation errors because now the signature changed. But with interfaces, there is no scope for change. It's going to remain the same thing forever. In fact, if you try to make changes to the signature of this method move, let's say, then you're going to have a compilation error. So there is no room for mistakes as well. So that's all what an interface is. We're going to take a look at some of the interesting examples going forward. Stay tuned.